So there are a couple different ways to describe lengths, or volume of wood is probably a more appropriate term. Most places, when we go to the lumber yard, most places are going to sell lumber by the linear foot. Okay, this board costs $3 a foot. Okay, and so if you have a 10-foot board, it's going to be $30 if you're quantifying it by the linear foot. The alternative is by the board foot. Okay, and if we talk about board feet of lumber, we're talking about the cubic volume of a piece of wood. Okay, and one board foot of lumber can be represented by a piece of wood that is 12 inches wide, 12 inches long, and 1 inch thick. Okay? That equals one board foot. If we took that same piece of wood, it was 12 inches wide, 1 foot long, except now it is 2 inches thick, we have 2 board feet of lumber. Okay? Or if we make it 2 feet wide, or if we make it 2 feet long. Okay? Let's say we had a board that was 2 feet long, 6 inches wide, and 1 inch thick. That would also be one board foot. Okay, we can talk more about this in the future, but the only place that you're really going to encounter board feet of lumber is at Almquist. Okay, Schmidbauer deals sometimes in 1,000 board feet, and you'll look at your receipt and it'll say like $783 for one stud. Okay, but that's actually giving you the price per 1,000 board feet, and it'll say MBF, M standing for 1,000, like millennium. Okay, all right, so a board foot is 144 cubic inches. Okay, so if we multiplied a piece of lumber 12 inches wide times 12 inches long times 1 inch thick, that would equal 144. And we would divide that by 144 to turn it into one board foot. Okay, there are 144 cubic inches in one board foot. Okay, so if we multiplied 12-inch width, 12-inch length times 1, that gives us 144. 144 cubic inches. There are 1 board foot and 144 cubic inches. Okay, so if we divided 144 by 144, we would get 1. Okay. Now let's take that same board and let's make it 12 inches wide, 24 inches long, and 1 inch thick. If we multiply those together, we're going to get 288 cubic inches. We divide by 144, that's going to give us 2 board feet. Okay, so again, Almquist is the place where you're going to regularly encounter lumber that is sold by the board foot. Almost every other place is sold by the lineal foot, but it's important to know people use this wrong all the time, especially on Craigslist. People say board feet when they mean lineal footage. So you need to understand what exactly we're talking about. Okay. Lots of different fasteners we're going to use to fasten the house together. Okay. And so one of the concepts I want us to kind of wrap our heads around is this idea of the structural membrane, or another term that gets floated around is the load path or load transfer. Okay. And what that means is we are tying all of the different components of the house together. We're attaching them all together with mechanical fasteners, and the weight of that entire structure travels through certain components in the house all the way down to the foundation. Okay. So common fasteners that we're going to use are nails. Far and away, the most common fastener we're going to use are nails. Okay. Screws we use somewhat sparingly when we're building a house. Bolts are used in certain applications, metal straps in certain applications, adhesives, not so much structural, but mainly for like squeaky floor remedies and stuff like that. Okay. But we're going to talk a lot more about this throughout the year. But when we think about that load transfer, the weight of the roof is primarily what we're trying to mitigate. Okay. The house is very top heavy. We want the weight of that roof to travel through the studs, through the framing, down to the foundation. Okay. And then we want all of those components to be attached together. Okay. Because banging a couple nails through something isn't enough to hold it together if there's 120-mile-an-hour winds blowing on it or an 8.0 earthquake trying to rip it apart. So, and again, we're going to talk more about this, but let's start at the foundation. Okay, we've poured a big piece of concrete in the dirt. Okay, all of the weight is going to go down to that concrete and then get distributed back to the dirt. Our concrete that we pour is going to have bolts sticking out of it. We're going to drill holes in the floor and actually bolt the floor down to the foundation, okay, the floor system. Then we're going to build walls on top of that floor system. Plywood is going to connect that wall system to the floor system. Then we're going to put a roof system, either trusses or stick frame roof, on top of those walls. And then those are going to be connected to the walls, either with really long screws or metal straps. Okay? There's some sort of mechanical fastener at all of those individual components that's tying the whole system together and directing that load back down to the foundation. Okay? If we don't properly fasten those, then those components could separate, and that could result in building failure. Okay? There's one very specific fastener that gets heavily utilized called a hurricane tie, and it's a metal strap that connects the truss or a rafter to the wall. And the reason it's called a hurricane tie is because in Hurricane Andrew, I think it was in 1992, the winds from that hurricane pressurized the house and actually popped the roofs off the houses. Okay, it separated the roofs entirely, blew them right off the houses. Okay, so they developed this mechanical fastener called a hurricane tie in response to that. And a lot of the code changes are very reactive. Okay, some sort of disaster happens, and then a company like Simpson Strong Tie, if you're going to encounter a lot, they develop some sort of fastener that's going to solve some sort of problem. Okay, but we're going to go over all this stuff in more depth, but just suffice it to say, most of the stuff that we're going to do is nailing. And we're going to use lots and lots of nails. Okay? So nails are most of the time smooth, okay, pointed fasteners, and you're either going to drive those in with a hammer or shoot them in with a nail gun. Okay? A lot of people ask me, why don't we use screws for this? Because they think screws are somehow superior. Screws are really expensive, really slow, and they tend to shear and break off when structural loads, i.e. wind, earthquakes, are applied to a building. Okay, nails are not as brittle as screws, so they can bend back and forth and have loads applied to them and resist those loads. Okay, whereas a screw tends to want to just break off. Okay, and then we're going to potentially have building failure. Okay, there are an awful lot of nails, different sizes, different shapes, different things that we do with them. Okay, so we're going to talk about some of those different kinds of nails, and it's really important that we're able to communicate with each other what kind of nails we need. It's important that we can read the plans and see that a certain type of nail is called out to nail a particular wall, and that's very common. Okay, a lot of times the engineer will specify a certain type of nail to be used to nail the plywood into the studs. Okay, so for the most part, nails are organized by length and the thickness of the shank. Okay, so This is the shank of the nail. This is the head of the nail. And so the length differs on the shank, and the thickness is different on the shank, depending on what kind of nail you're using. So a lot of times nails are like have a penny or a D attached to the end. Like people will say, I need some 16 penny nails, 8 penny nails. We're using 16 Ds, okay? Ds, pennies are interchangeable, and it's kind of silly, kind of antiquated, but the D, from what we can tell, is from I think it's the Roman word for coin, denarius. Okay, that's where that comes from. And the reason we call them penny and associate the D as a coin with them is because, as far as like we can tell through like anecdotal evidence, this, if we're talking about like a 16 penny nail, it costs 16 pennies to purchase a pound of those nails. Okay, 8 penny nails, it cost 8 pennies to purchase a pound of them. Obviously, that was a long time ago, a long time ago. Okay, or maybe it was 1,000. I don't know how much it bought, but it doesn't matter. Okay, it means nothing now, other than it does refer to the shank. Okay, the penny, the D, has nothing to do with how much they cost anymore. Okay, but it refers to the thickness of the nail, which is different than a common nail. Okay, so if you're looking at your plans and you see 10 Ds called out for nailing or 10 commons, you have to make sure that you're getting that particular nail. Okay, most of what we use is going to be 8s or 16s. Okay, 8 nails are generally used for attaching sheet goods to framing, and then 16s are generally used for attaching framing components together. Okay. There are different coatings on nails, and they tend to change the property of the nails. Okay, so if I talk about brights, I'm just going to say never buy brights. There's no reason to ever buy brights. They have no coating. Okay, don't buy brights. Use sinkers for framing. If we're attaching sheet goods to framing lumber, if we're nailing studs together, use sinkers. Sinkers have a vinyl coating on them that essentially lubricates the nail and makes it easier to sink the nail. Okay, we're going to watch some videos by the legendary Larry Hahn. Okay, he is like the Chuck Berry of carpentry. Okay, we're going to watch some videos featuring Larry Hahn, and I'm not quite sure of the origins here. He was either around when they did this, or he kind of was the first person to do this, but all they used to have were brights back in the 50s. Okay, they were really slow, they were hard to drive. So what I think Larry, or at least his contemporaries, started doing is they would get a big box of brights, dump them into a bucket, throw a block of paraffin wax into the bucket, and dump a bunch of gasoline in there, swirl it all around, and the gasoline would melt the wax, and it would coat the nails, and it would, like I said, lubricate the nail and make them really easy to drive. Okay? Some nails are galvanized. Okay? When we talk about galvanized nails, they have a zinc coating. Okay? And there's a couple different ways to make a nail galvanized. One is electro galvanized, which those aren't as good. If we're talking about hot dipped galvanized, we take those bright nails and we actually dip them in molten zinc. Okay, and that zinc protects the nail and inhibits corrosion from occurring. Okay, if we use brights or sinkers outside, they're going to rust. All right. I want to look at this real quick. HDG versus GVS. Okay, this is what it says on the box of nails. Okay, if you go to the lumber yard and get a 50-pound box of nails, it's going to say 16 HDG or 16 GVS. Which one do I get? Okay, depends on what you're trying to do. If you are framing, you want to get GVS, green vinyl sinkers. They're going to be really easy to drive. They're going to be really easy to pull out if you need to. You don't want to use galvanized nails for framing because they're really hard to drive and they're brittle. Okay, we want to use galvanized nails for exterior trim, exterior finishes that are going to be exposed to the elements and they're going to be rust resistant. Okay, we already kind of talked a little bit about sinkers, but they've got that vinyl coating that makes them easier to drive. They also have a waffle head on the end of the nail. Okay, they have this checkered, knurled pattern on the head of the nail that makes it easier for your hammer to grip the nail. It's less likely to slip off the nail as you're driving those nails in, okay? We can't use these outside. I've seen some really awful homeowner type work where they built fences or decks using sinkers and they just rust within days, especially around here. It's just wet all the time and you'll have these rust streaks all over everything, okay? Most of the framing, structural sheathing that we do is going to use sinkers because they're so easy to drive, okay? I mentioned this before already, but I'll say it again. We're going to use 16 sinkers if we want to nail framing components together. We're going to use 8 sinkers if we're nailing plywood into framing members. Okay, so exterior sheathing, we're going to drive 8s through the plywood into the studs. We're putting down the subfloor, we're going to drive 8s through that subfloor plywood into the floor joists. We're putting plywood up on top of the roof, we're going to use 8s to drive through the plywood into the trusses. Galvanized nails, we'll talk a little bit more about these. The nickname is Galvies. Give me a box of Galvies, okay? They have a zinc coating, like I mentioned before, that's going to inhibit corrosion. So if we're putting up exterior trim, if we're building a fence, if we're building a deck, anything that's potentially going to get rained on or fogged on or drizzled on needs to have galvanized nails used, okay? The other thing is, if we're using these nails with redwood, cedar, or treated lumber, we have to use galvanized nails, okay? Redwood and cedar have tannins in them that protect the wood from fungal or insect attack, okay? It also acts as a corrosive agent on regular steel nails. So, galvanized nails are the kind of worst, best option for nailing into redwood or cedar. Realistically, we want to be using stainless or aluminum nails because those are never going to corrode. The galvies are eventually going to fail. Eventually, they're going to lose that galvanized coating, okay? And then the thing with the treated lumber, if we're nailing into pressure-treated lumber, it's interesting. We're using galvanized nails to prevent the galvanic process from occurring, okay? I mentioned before when we talked about pressure-treated lumber that they inject the wood with a bunch of poison, essentially, okay? The poison used to be arsenic, okay? It was an actual poison that would actually kill people if they were dumb enough to eat the pressure-treated lumber or burn it or something like that, okay? We've gotten away from that chemical, okay? It wasn't just harmful to us, it was just bad for animals, the environment. We didn't want to use that stuff anymore, okay? The new poison that we're using is copper-based. When copper reacts with the steel in wet locations, it causes the nail to corrode. Okay, it's a galvanic process. It's kind of the same way that like batteries work. Okay, we can talk more about this in the future. But if we're nailing into just untreated lumber, sinkers are fine. As soon as we nail into a piece of pressure-treated lumber, we need to use galvanized nails.